Find the most general form of the antiderivative for the following indefinite integral. So here, again, we want to start, if we look at this integrand, it's not in the form of any of our known general antiderivatives. So the first thing we need to do is rewrite this. And so if we rewrite this, if we factor this 1/3 out to the front, we have 1/3 multiplied by sine of 5x squared. And we realize, darn, this is still not an antiderivative. So at this point, we want to think back to our trigonomic identities. And what I want you to do is recall the half-angle formula. So we have our half-angle formula. So if we want to let k be some real number, some arbitrary constant, if we have sine squared of kx, this is equal to 1 minus cosine of 2kx, all divided by 2. So we'll use our half-angle formula here to help us rewrite this expression as something we can integrate or anti-differentiate. So I'll still keep this 1/3 out in front, and we're going to rewrite sine of 5x squared as 1 minus cosine of 2 times 5x, all divided by 2. And so this is 1/3 multiplied by 1 minus cosine of 10x, all divided by 2. And then to make this anti-differentiation even easier, I'm going to pull this 1/2 in the denominator out so that we have 1/3 multiplied by 1/2 multiplied by 1 minus cosine of 10x. So this leaves us with 1/6 multiplied by 1 minus cosine of 10x, which we can definitely anti-differentiate no problem. So giving ourselves more room, we're ready to anti-differentiate. And so we now have 1/6 multiplied by the integral of 1 minus cosine of 10x dx. And so let's think about the anti-differentiation rules that we need. We have this constant 1. So to integrate here, we think for some constant k, the integral of k dx is equal to that constant k times x plus c. And then again, for some constant or real number k, the integral of cosine of kx dx becomes sine of kx, all divided by k plus c. So we'll use this for our anti-differentiation. So this is equal to 1/6 multiplied by x minus sine of 10x, all divided by 10 plus c. And this is our beautiful final answer.